Guys, we have three internal forces. One called axial force, which is tension or sometimes compression. The second one called shear force. The third one, which called bending moment. So if you are using structure analysis for any structure, I can draw axial force, shear force, bending moment. From axial force, I can get P ultimate. And this P ultimate can be tension or compression. And we learned it in truss design. How can we design a member under tension or a member under compression? And also last meeting, we learned how to design a column under the effect of compression. Shear force diagram, from the diagram, I can get V ultimate. And we decided that V ultimate must be smaller than or equal phi Vn, which is mainly supported by web of the cross section. And also, we learned how to design beam. If you draw bending moment diagram, I can get the M ultimate. This M ultimate must be smaller than or equal phi Mn. So right now, at this moment, we can design a member in truss under tension, a member in truss under compression, or a column under compression. We can do it. We can check for any cross section against shear. We can design any beam against moment. We can do this. Last meeting, I told you sometimes this moment can be divided to M ultimate X, M ultimate Y in one case. If you have rafter, which is a sloped beam, but this is not the problem. This sloped beam is supporting another beam in the case of Berlin, for example. So your force is vertical, but the beam is inclined, is tilted. So we can expect the two components for moment, M ultimate X and M ultimate Y. In this case, we have to use interaction equation, M ultimate X divide phi Mnx plus M ultimate Y divide phi Mny smaller than or equal 1. That makes sense? For shear force diagram, no way for this shear to be combined with another. Probably can be combined with torsion, but torsion is out of the scope of this course. So no way to find shear force combined with something else. But in some case, we can find axial force combined with bending moment. Really? Yeah. From structure analysis, we learned something called frame or frames. Sometimes we have frame, column, supported or connected with beam, with connection here. This connection is rigid connection. And next week, we will learn something about this connection. This rigid connection will make this column, I cannot say we have a column and we have a beam. No, we will have a frame because this member and this member and this member looks like one unit. So we have frame. This frame, under the effect of dead load, life load, wind load, snow load, we can expect 3 diagrams. And I believe you learned how to draw this diagram during structure analysis. We will not go back to the structure analysis because we have Risa right now can do it. So we can draw normal force diagram, shear force diagram, and the bending moment diagram. If you would like to check against shear alone, because shear is not combined with something else, we learned how to check against shear. V ultimate from this diagram. Then I can check the cross section. But go ahead and see this column. I'm sorry, I cannot say column. This member has P ultimate. At the same time, this member has M ultimate. Wow. If this member under the effect of B ultimate only, I can say it's a column. If this member under the effect of M ultimate only, I can say it's a beam. But this member in this frame under the effect of these loads has both of them, P ultimate and M ultimate at the same time. So this member cannot be beam, cannot be column, but I can say this member is a beam column member. I'm trying to explain why I'm saying we are going to design beam column design. What does it mean? Means if you have a member under the effect only B ultimate, this member can be called column. If you have a member only under the effect of M ultimate, moment only, this member can be called beam. But because this member in a frame, so we have three internal forces at the same time: axial, shear, and the bending moment. I don't care about shear because shear is alone, different. So this member will be under the effect of P ultimate and the M ultimate at the same time. So I can call it beam column member. So if you see this expression, beam column member means this member has M ultimate and P ultimate at the same time. Does that make sense? Did you understand this point? If you are designing beam member, that means you have M ultimate only. If you are designing column member, that means we have P ultimate only. If you're designing beam column member, that means this member under the effect of M ultimate and P ultimate at the same time. This will not happen only in one except one case, if you have frame. If you are designing your structure and this structure is frame. And we will go through what is the meaning of frame next week. But right now, we have a design called beam column design member subject to bending plus axial compression load simultaneously at the same time. Any questions so far? Any questions so far? It's very easy, don't worry. I believe the design step is very easy. It's a donkey work. The only thing we need to pay attention is the structure analysis step. Because if you can figure out what is the correct value for M ultimate, what is the correct value for P ultimate, what is the correct value for V ultimate, I believe you can select the safe cross section. So the structure analysis and loading are the most important step. But for design, no, it's very easy. Nothing serious. But any questions so far? Okay, we have two cases. The first case, if P ultimate divide phi Pn greater than or equal 0.2. Phi Pn, how can I get phi Pn? You learned it before, how to get phi Pn. There you go. If this member is a column alone, I can get the compressive design strength, phi PL. So we need to figure out the compressive design strength first and check P ultimate divide phi Pn is greater than or equal 0.2. I'm going to use this interaction equation. If this not happen and P ultimate divide phi Pn is smaller than 0.2, I'm going to use this interaction equation. The interaction equation is very simple. P ultimate divide phi Pn plus 8/9 M ultimate divide phi Mn. We can remove this X. It's not a big deal. Yeah, we can remove it. Okay, or the second case, P ultimate divide 2 phi Pn plus M ultimate divide phi Mn must be smaller than or equal 1. Phi Pn design compressive load, P ultimate applied axial load, this one from structure analysis, phi Mn design bending strength, M ultimate applied ultimate moment from structure analysis. If the result is not very close to 1, try another shape. I told you this point last meeting. We will assume cross section and we will check if this side or even this side is not very close to 1. That means you have cross section which is not economic. Try another one. Continue the process until a shape is found that gives an interaction equation results less than 1 to be safe and close to 1 to be economy, like 0.9 or more. So we would like this side to be something between 0.9 and 0.99. 0.99 means safe, 0.9 means economy. Let's see this example. This member, I cannot say, guys, this column or this beam. I cannot say this, but this member has M ultimate and P ultimate. Sure, yeah. Can you see the given applied load? We have here axial force, B dead load, B life load. So I can figure out the value of P ultimate equal 1.2 dead plus 1.6 life. 1.2 time 54, 1.6 time 147. So the value of P ultimate will be 300. Hip. This member has M ultimate. We have moment here due to dead 18, due to life 49. So we have 1.2 dead load, 1.6 life load. So 1.2 time 18, 1.6 time 49. So 100 kip foot. So this is the reason why I said this member. I didn't say this column or this beam, because this member is beam column member. One more time, what is the reason behind this expression? Because this member under the effect of axial force and under the effect of bending moment at the same time. So this column, or I'm sorry, this member will be designed as beam column design. First of all, we have W shape. So this column or this member looks like W shape. Something like this. We need to select one. From steel A999, that means if yield equal 50 KSI. And the buckling K equal 1 and the member length is 16. So the first step we need to select. So assume We have W, no guide. So you are, if you are lucky, you will select the correct one. Okay, go ahead and select one. I have no idea which one I can use. So let's try. I will not say to select the highest cross section or the lowest one. I will say you can select something in between. So for example, W 24 times 68. I will start with this one, for example. So let's say 24 times 68. Don't ask me why you select this cross section. I will say you can assume what you want. But for my opinion, I will go to the middle of this table and select one in between. And then I can decide to go up or go down. You know what I mean? Because if you choose the highest cross section in the table, you don't have any guide. If this one is more safe, you don't have any guide. But if you select one in the middle, probably you can decide to go up or go down. And you can decide how much you can go up or how much you can go down. So I will select this cross section W 24 times 68. This one. So this one can give me R X 9.55. RY equal 1.87. I capital X, I capital Y, 1830. I capital Y, it will be 70.4. Start. To start your design, we need to check. We are in this case or this case. Right now, I can figure out the value of P ultimate, which is 300 kip. Can you tell me what is the value of the denominator phi Pn? To do this, I need to go back to the design of a column. Assume we have a column. So I need to figure out. So I need to check KL divide R. What is the value? KL divide R. K for X and Y are equal 1 times L 16 feet. I will multiply it by 12. Divide R. Which R I'm gonna use? I'm gonna use the smallest one, 1.87. So the value right now $102.7. Okay. What is the value of 4.71 square root E divide F yield? E 29,000 divide 50 under square root times 4.71. This value will be 113. So the situation right now, KL divide R, which is the cylinderness ratio, is smaller than 4.71 square root E divide F yield. So what is the meaning? The meaning is the value of FR, which is F critical, equal 0.658, F yield divide FE, F yield, 0.658. So right now, the value of F critical equal 0.658 to power F yield divide FE, all of them time F yield. That's right, 658. Yes. Okay, what is the value of FE? I think we have a expression here. By square E divide KL divide R square. So by square E KL divide R square. By square time 29,000 K1 L 16 times 12. Divide R 1.87, all of them square. So 16 times 12 divide 1.87, all of them square by square. This value will be 27.15. So F critical will be 0.658. F yield 50, divide 27.15, all of them to time 50. What is the final value? It will be 23.13. So phi Pn equal phi F critical time area gross. This is what we learned before. Pn equal F critical area gross time phi. Phi equal 0.9. So 0.9 F critical 23.13. What is the value of area gross? I forget to bring it out. The assumed cross section has area gross equal 20.1. So your final answer will be 418.46 kip. Guys, I would like to remind you what you are looking for. I would like to decide this one will be valid or this one. So I need to figure out what is the value of P ultimate divide phi Pn. So P ultimate divide phi Pn equal phi Pn right now 418.46. What is the value of P ultimate? 300. So what is the final answer? It will be something like 0.71. Wow. 0.71, I believe it is greater than 0.2. So which interaction equation I'm gonna use? I'm gonna use the first one, the first interaction equation, which is P ultimate divide phi Pn plus 8 divide 9 M ultimate divide phi Mn should be smaller than or equal 1. We still need one more step. Do you know why? Because this value is given, I can figure it out. This value I calculated, this value I did it. I still need phi Mn from table or equal phi F yield times Zx. You have two choice. This choice, or you can get it from table. Let's do it from this expression, 0.9 times F yield 50 times Zx. Please go back to the table. This cross section has a value for Zx here, 177. So I can figure out the value of phi Mn. 0.9 times 50 times 177 equal, yeah, that makes sense, 7,965. But be careful please, because this one is KSI, so kip per square inch. This one is inch cube, so the final answer will be kip dot inch. I would like to convert it to kip foot. Do you know why? Because the given moment or ultimate moment, M ultimate, is 100 kip foot. Each moment we would like it to keep it kip foot. So this one is kip inch. I will divide it by 12. So your final value will be 663.75 kip foot. Go ahead and set up your interaction equation. P ultimate 300. Phi Pn, we just calculate it, 418.686. That's right. 0.46, I'm sorry. Plus M ultimate 100 divide phi MN, which is 663.75. What is the value? I believe we will be safe, but do you think it's more safe? Or what do you think? 100 divide 663.75, 0.86. It's smaller than 1. You are safe. And for my opinion, you are good. I believe 0.86 will be good. 0.86 will be good. So the final conclusion for this member, it will be constructed using this cross section. W24 times 68. One of you, like Burak, will say, no, 0.86, I think this cross section is more safe because we have very limited resource. We have very limited money. We need to reduce the cost as much as we can. So I will select another cross section. Anybody can tell me which cross section you are going to use? You need to go up or go down. So now you can decide. I believe you need to go down. So if you would like to reduce the cross section W24, probably you can go for W21. W21. We have W21 times 48, for example. You can try it. We need the final conclusion, this number to be smaller than 1 and very close to 1. You know what I mean? Smaller than 1 to be safe. Close to 1 to be economy. But for me, as Ayman, no, I will say this cross section will be good. I believe 86 will be good. So the final conclusion, this member will be 24 times 68. So any question? Does B, D, or P, life and dead signify that it has been factored already? No. If these values are given without any comment here in the problem or anywhere that these loads are factored, you are assuming dead and alive without factor. If something else, something will be written here. But if nothing is written, no note, no nothing, okay. So we have to multiply them by factors. These values are surface values, not factored values. So I have to multiply dead by 1.2, life by 1.6. If you are solving using RISA can give you the final answer without any modification. So P ultimate and M ultimate will be given directly from RISA because you're already doing load combination inside RISA. Okay, so guys, if you are designing any steel member, please, you have to decide before starting where you are. Do you have M ultimate only? So please go ahead and use the steps for beam design. Do you have B ultimate only? Only? From structural analysis? Okay, go ahead and follow the rules for column design. But if you have both of them, and this will not happen, except if you have frame. That means we have M ultimate and B ultimate at the same time. So this member can be called beam column member. It works as a column and the beam at the same time. So we need to follow up the rules to design beam column member by using this interaction equation. But before starting, you have to decide which interaction equation I'm going to use, this one or this one. So we need to check this condition and this condition to decide. if you're designed based on interaction equation, be careful. We need your left-hand side to be smaller than 1 to be safe, and very close to 1 to be economy. Can you see? Continue the process. What you mean by continue? Try another cross-section. Try to assume another cross-section until a cross-section is found that gives an interaction equation results less than 1 to be safe, and very close to 1, something greater than 0.9. This is a guide. But remember that the main target to be less than 1. The second target to be economy between 0.9 and 0.99. So this is the second one. But the main one is smaller than 1. And during your exam or homework, just give me a hint. Is it safe, unsafe? You need to increase, you need to decrease. Just that's it. Don't repeat your calculation.